3, 2, 1, engine ignited. And we have liftoff of SpaceX Falcon 9 rocket and Dragon.
It's the biggest firework you've ever seen. Absolutely fantastic.
Delivers new science and technology to the International Space Station.
The absolute extra bit of it is that we know in the Dragon capsule sitting on the top of it is like our experiment.
First stage propulsion performing nominally.
My name is Simon Gilroy and I'm a professor of botany at the UW-Madison Botany Department. Research questions that we're interested in are all related to how plants deal with environmental stress. One of the practical aspects of the experimentation is to try and work out what happens to plants in space with the long-term goal of being able to use them as part of a life support system for the astronauts. It takes a lot of people to do that, and there's the Madison people and there's NASA people. Putting just one seed into space is a big deal. We actually ended up putting 1,200 seeds into space. They grew for a week, they were chemically stopped, and then it came back down on the same Dragon capsule that took it up after about a month. So we got our samples back. Another one of the research team, Wang Yu, has been going through and beginning to do the extractions. Take the seedlings, we then do some chemical extractions which allow us to concentrate and purify the RNA. We will send those samples off to the biotech center here, and the biotech center will run a technique called RNA-seq on it, which will tell us the level of every gene in the entire genome. You may think that putting the thing into space and getting it back and extracting it and waiting 2 years to get your data, that's the hard part. No, the hard part now is going into this pattern-rich data and saying, well, what went on? Can we see the pattern of low oxygen in these samples? Can we see the pattern of touch? So that is years of analysis that will come after we get that data back.
So we have bigger plants, they're grown in light. What other opportunities does this new experiment have?
We've been continuing our space research, so we've got some insights into how plants appear to be operating in space. The more we understand about how plants operate in space, the more easy it's going to be to design the hardware and the way you cultivate the plants to let you actually grow them reliably in space.
Cheers, cheers, cheers.
Very recently, that NASA program managed to put lettuce up on the International Space Station.
That's awesome. Good. Tastes good.
And so this has been grown on the space station, and they get to eat it. And so, of course, in parallel at UW, we grow exactly the same plants, and at the point where they're eating them, we pull out our plants, and in solidarity with the astronauts, we're eating the same lettuce on Earth. It was awesome.
So station 2 for veggie, the 5 other pillows work without any problem.
That's great to hear.
Getting to the point of having a relatively simple piece of equipment where you can grow plants and they get to the size where you can harvest them, that's an enormous step forward.
Here on Earth,
our next experiment is to test the idea that in space, because liquids flow in a different way and gases move in a different way than on Earth, that plants are suffering effectively a flooding stress. It's as if they're growing in a field that's been flooded, even though you haven't flooded them. What we need to be able to be doing is doing research to address things like flooding stress or things like radiation stress and things like that. Take yourself mentally back to when people first started doing agricultural cultivation of crops. And they were trying to work out how to water them, where to plant them, how to select varieties. And we're thousands of years down that road. And so agriculture is incredibly efficient on Earth. And we're right at the dawn of doing space agriculture. It's a really, really unique opportunity for us.